Okay, let's take a look at homework 32, number 21. It says the radioactive decay of SM-151, an isotope, can be modeled by the differential equation dy dx equals negative 0.0077y. Well, if we look at this, we did this earlier in class, we actually derived this again, that if we've got this differential equation, it actually derives to be this by solving it. I don't have to solve it again, so we can use this. And this is your k, so what we have over here is they gave you the differential equation for number 21, so that they said that dy dt is equal to negative, where is it at? Okay, negative 0.0077 k, I'm sorry, y. So we can derive from this that k equals negative 0.0077. That's k. That's the k that's over here. All right, so you see how that coordinates. Okay, ky, kt. So k is that. They could derive it, but we already did it earlier, so we can go from there. And we want to find the half-life, so we could just set this up now into this equation. Say y equals y sub 0 e, and then my k I know is negative 0.0077 t. Now the half-life we're looking for, so we know that the ratio of the amount I started with over the amount I have will be y over y sub 0, and that's going to be equal to a half, or 0.5, and that's equal to e to the negative 0.0077 t. So I want to find out what t is, what the half-life is, okay, the time when I have half of my substance. All right, so I can take the natural log of both sides. Natural log of 0.5 equals the natural log of e to the negative 0.0077 t. Then I'll bring that in front, like we've been doing. So the natural log of 0.5 equals negative 0.0077 t times the natural log of e, but the natural log of e is just 1, so this is what I have. And then if I divide both sides by my k here, 0.5 divided by negative 0.0077, I get t. If you work that out in your calculator, you should get approximately, and that would be 90.019, and that would be yours. Now remember, we know this is negative. We talked about this earlier, so this is negative, so negative divided by negative is a positive. So that should take care of that. So that's our half-life. Okay, hope that's all right. Okay, number 23. You kind of have to read 23 and get your data from what the problem is saying. And basically, we have a condition situation here, and it's it says suppose that cholera bacteria in a colony grows unchecked according to the law of exponential change. So this is my law of exponential change. Now we derived this again earlier, so we don't have to rederive it. That's what that is. Y sub 0 is my initial amount. K is what I usually have to determine, time, and this is the amount I have at any given time. Okay, so it says the colony starts with 1 bacterium. Well, that's nice, so that makes my y sub 0 is 1. Okay, and it says doubles every half hour. Well, I need another point. Remember, we need a couple points so we can find the k. Well, after 1/2 hour, if it doubles, I've got 2. So this is my data. So after, when t is 0.5, y is 2, so I'm going to use that to find my k. All right, so we know that y equals, and then y sub 0 is 1, so just 1 times e to the kt. And then I'm going to try to find out what my k is, so that'd be easy, because I know that y is 2, e to the k, when t is times 0.5. And I'll try to find out what k is. So that won't be too hard. I just take the natural log of both sides. So the natural log of 2 equals the natural log of e to the, I guess I could write 0.5k. I'll bring that down in front, so I'll have the natural log of 2 equals 0.5, that's a lousy 5, sorry about that, 0.5 k, the natural log of e, which is just 1, so if I divide both sides by 0.5, I get k equals the natural log of 2 divided by 0.5. I can put that in my equation now, my original equation, and y equals, and remember my y sub 0 is 1, so that'd be e, and my k is the natural log of 2 divided by 0.5, and I can leave it like this, times t. And they want to know how much we will have in 24 hours, so that's just going to be y equals e to the natural log of 2 divided by 0.5 times 24. And that's going to be approximately 2.81 times 10 to the 14th. Now the way you put that out in the calculator, I kind of worked it so you can kind of see how I put it in the calculator. If I can get this in here, there's my calculator. Let's see if I can get it. There you go. So you can see that. E raised to, and you got to use a lot of parentheses. Let me get this. There you go. So you got to use some parentheses there. And you got it. So that's e to the, and a parentheses, natural log of 2 divided by 0.5 parentheses times 24 power, and that's what you get. Okay, I hope that's okay. If you have any questions, drop me an email.